The Campine region, northeast in Belgium. Its sandy soils harbor a typical vegetation which is dominated by heathlands, intermingled with some colorful legumes, and pine forests. This region provides the only national park of Belgium, and it also tells a story about the past. And this story is written down below the ground. But because the Campine region is as flat as Earth is according to a certain society, we need an artificial window in history. This window is provided by over 50 years of heavy digging. When a continuous roar of man-made machinery digging for valuable materials in the Campine soil finally went mute, nature took over again. And it left us with a nature reserve that offers a peek into history. This former quarry reaches deep enough in the soil to go back millions of years. Our dive into the past first brings us all the way down to the water surface. The water is gently caressing a soil layer that's celebrating its 15 millionth birthday, approximately. It consists of bright white sands that have been deposited under subtropical conditions in a shallow sea. Yes, our current maritime climate makes way for much warmer summers. While warm temperatures were sizzling in the air, the wave movements of the sea covering the current Campine region ensured that a nicely sorted sand blanket settled on the bottom. But how did those sands become so bright and shiny white? Well, it turned out that nature provided its own heavy chemical cleaning of the sands. This free-of-charge industrial purification was caused by a next change in our Campine environment. The sea suffered its own Waterloo as continental conditions took over her reign. As the sea retreated, coastal wetlands, not unlike the current Everglades in Florida, decorated the Campine region. The subtropical conditions were kind to cypress and palm trees, which flourished in the wet environment. Driftwood from these trees slowly but steadily accumulated underwater. Undegraded material led to peat, and peat led to lignite or brown coal. And lignite is what we still see these days, as a pitch black layer that beautifully contrasts with the underlying white sands. The credits for this natural black and white harmony go completely to the lignite itself, as it are the humic acids leaching from its organic matter that provided a heavy chemical cleaning of the sands. Wood fragments are still distinguishable and provide a throwback to the golden days of wetland trees in the Campine version of the Everglades. But even subtropical dreams of shallow warm seas and flourishing coastal wetlands come to an end. Around 2.5 million years ago, the Pleistocene time period brought along brutal changes in climate. The Campine region did not escape and was also hit by multiple ice ages. Temperatures dropped deep and oceans retreated as water was stored in massive ice sheets. Only plants and animals strong enough to deal with these harsh conditions were able to survive in the region. But even during ice ages, there are summers. And melting ice from higher areas leads to huge quantities of water that has to find its way to the sea in the form of rivers. One of those rivers was the Meuse. But not the Meuse as we know it today, which is a single-bedding river in the meandering system, but more like an Ice Age alter ego of the current Meuse. A braided river consisting of many shallow streams broad enough to cover a huge part of the Campine region. And as it bursted into the Campine plain, the Meuse brought along souvenirs from upstream mountainous areas where erosion had free rein. These rocky souvenirs became scattered all over the area. Gravel of all different sizes, ranging from small pebbles to massive stones weighing multiple tons, arrived to the Campine region. This scene repeated itself numerous times, and the result was a lasagna of randomly sorted gravel layers up to 15 meters thick. Not unlike lasagna, this gravel is characterized by a red color. This red appearance finds its origin in yet another climate and vegetation, which in this case was similar to that of the lasagna motherland, a Mediterranean vegetation. Weathering and soil formation under these conditions resulted in red-colored iron substances spreading throughout the gravel. But now, these Mediterranean intermezzos did not mean that ice ages were done for, because many cycles of cold episodes were still to come. The last chapter of the Campine history book written in soil starts off towards the end of the last ice age. Cold conditions still governed over Europe, and a dominant northerly wind gave a free ride to vast amounts of sand on a one-way trip towards the Campine region. These sands piled up to form the base layer on which most current Campine soils have developed. As the last stage slowly took its last breath, the cold kingdom surrendered to milder temperatures and a more extensive vegetation. But this last sandy act of the dying ice age left its significant mark on the current Campine region. The sandy top layers enforced their own favored vegetation by providing low nutrient concentration, higher acidity and high porosity. And these properties paved the way for the creation of the signature soil type of the Campine region, potsols, with their typical white, bleached horizons sandwiched between darker layers. And that is how we arrive to today. It is clear that massive changes have occurred over time in the Campine region, and the major driver behind this all is the climate. It requires little imagination to realize the burden that this has caused on life on this planet, and that humans would have been extremely challenged to survive through all these changes. Climate change is not what we want for a stable and certain future. But yet here we are, inducing climate change through our greenhouse gas production, and not over the course of millions of years, but over the course of less than 100 years. Let the history lesson written in the Campine soil be a reminder on how important it is to look after our Earth. By taking care of our environment, we make work of a better future for all life on this planet.